Hello, welcome to this presentation on proteins, part 2. Today I'm going to discuss to you the second part of protein, and in this lecture you will learn the different structures of proteins. So let's go. Okay, so in the previous lecture, I uh, I showed to you the structure of different amino acids, and as you can see in this slide, um, I have here the structure of um, or primary structure of insulin. Insulin is the very first protein that has been sequenced. When I say sequenced, um, the amino acid um, the amino acid content has been or have been identified, the amino acids in order. So as you can see in this in the picture of insulin, there are two chains, and then from your left side to the right side, what appears are the following: glycine, isoleucine, valine, glutamic acid, glutamine, and so on. Okay? The rightmost amino acid is asparagine. And on the chain B, you have phenylalanine, valine, and on the last amino acid in the chain B is alanine. Now, um, as you can see here, there is a sequence. Okay, my insulin and your insulin must have the same order of amino acid. Okay, this should not be, the order must not be altered. Okay, as you can see here, there are how many amino acids in the chain? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. This is the 21st amino acid. If I'm not mistaken, um, counting. Okay, now these amino acids are linked together. They are not separated, although in this in the picture you don't see a bond. But basically, each of the 21 amino acids are connected by each of the 21 amino acids are connected by a bond, similar to the amino acids here in the chain B. Okay, so you call the bond peptide bond, or in this is also known as amide bond. Okay, so at this point we will see how peptide bond is formed. Okay, by convention, in practice, normally the amino acid sequence in protein is read from left to right. Okay, so from your left you have glycine, and then on your right you have asparagine. Okay, so we read the amino acid sequence from N to C terminal. Okay, from your left side to the right side. Okay, and at this point we will see how peptide bond or peptide bonds are formed, or in other words, how amino acids are linked together in a protein. So I have here the this is how peptide bonds look like. Okay, this is the peptide bond. Okay, and this is another peptide bond. So in this structure, this short these short peptides, okay, have three amino acid residues. Okay, when I say amino acid residues, okay, these are the amino acids that are part of the protein. So here in the chain A, in the chain A of insulin, there are 21 amino acid residues. Okay? Take note that I added the word residue because I'm referring to the amino acid that is part of the protein. Alright. Now, if the amino acid is separated, or if I'm referring to individual amino acid, I would just say amino acid. But if I'm referring to amino acid that's part of the protein, I would refer to it as amino acid residue. Okay? So in this short peptide, okay, in the short peptide, there are 3 amino acid residues. By the way, if it is if there are only 3, or if there are only 2 or more, if there are 2 or more amino acids, okay, in the chain, we just call it peptide. In our case, um, picture, there are 3 amino acids residue, so we just call it tripeptide. Okay, tripeptide because there are 3 amino acid residues. The word protein or polypeptide is used when we are referring to a large molecule or large if there are many amino acid residues, okay, connected. So if there are only few amino acid residues connected, we refer to this as a peptide, oligopeptide, short protein. Okay, so here there are 3 amino acid residues in the peptide or in the tripeptide. So that's alanine, phenylalanine, and serine. Okay, the 3 amino acids are the 3 amino acid residues are connected by peptide bond. So this is one peptide and another peptide. So as I said, this is a this is tripeptide. Okay, tripeptide because there are 3 amino acid residues, and the tripeptide is connected by how many peptide bonds? There are 2 peptide bonds. Okay, the sequence is named using the 3-letter abbreviation: alanine or ALA for alanine, Phe for phenylalanine, and Ser for serine. Okay, however, we can also use the 1-letter or single letter abbreviation for each. Say for example, for ALA you have A, and then phenylalanine is F, and serine is S. Usually, we use the single letter abbreviation if the protein is very large. Okay, something like hemoglobin. Okay, and if we are referring to a very long, okay, polypeptide, because if we use the name or the complete name, the sequence would be very large. Okay, even if we are using the 3-letter abbreviation, the sequence would be very long. Okay, and we don't want large space. That's why biochemists or scientists have simply use or adapt the single letter abbreviation. Okay, previously I showed to you the structure of tripeptide. I have shown you the form in which the 3 amino acid residues are connected. Now the question is, how do we form peptide bond? Okay, in this structure or in this picture, I'm going to show you how the peptide bond or peptide bonds are formed. Okay, so let's refer to this as amino acid 1. Okay, and this is the amino acid 2. Okay? So remember that on the left side you have the N, okay? You have the amino group. On the right side you have the carboxyl group. And likewise in the amino acid 2, this is how we draw. Okay? R stands for the side chain of the amino acid. Okay, and the good thing about this is it's color coded. Okay, what we will do is we're just gonna remove this OH here from the carboxyl group, and we remove the hydrogen from the amino group. Okay, and remember that an amino group, the nitrogen here, has lone pair of electron. Okay, has lone pair of electron, and the lone pair of electron in the nitrogen will be used to form a bond. Okay, between the nitrogen and the carbon. So when this nitrogen bonds to the carbon, and this is actually the peptide bond. Okay, the carbonyl group remains. Okay, the nitrogen here is attached to the carbon. The one hydrogen here remains. Okay, and if you recall my presentation in organic chemistry, I told you that an amide, okay, has a general formula of R, or any alkyl group, or any group of carbon atoms. Okay, it has a carbonyl. Okay, the whole thing, this is carbonyl group, remember, and it's connected to amino group. Okay, does not matter if you put the hydrogen above. So this is the peptide bond. Okay, now as you notice that in the amino acid 2, this is the amino acid residue number 2, the carboxyl group, okay, the carboxyl group is unaffected. Okay, the carboxyl group is intact. Okay, and on the amino acid 1, okay, the amino group is intact. Okay, it's not part of the peptide formation. However, the carboxyl group of amino acid 1 is used in the peptide formation, and then the amino group of the amino acid 2 is used in the peptide formation. Now, by convention, as I said, we read or we identify the sequence beginning from the left to the right. Okay, from left to right. Now, the leftmost amino acid residue is called the N-terminal. Okay, and the amino acid residue at the rightmost in the sequence is called C-terminal. Okay, now let me explain to you why the leftmost amino acid is referred to as N-terminal. As you can see in this picture, okay, in this picture, the end, or the leftmost amino acid has free amino group. Okay, so the leftmost amino acid in the chain has free amino group, meaning the amino group is not involved in the peptide formation. Okay, and the amino acid residue at the right side, okay, extreme right, has free, okay, it has free carboxyl group. That's why it's called the amino acid at the C terminal. Okay? C terminal. So, if you have a sequence, say A, C, V, G, and then F. Okay, I have how many amino acid residues? I have 5. So, you call this penta. Okay? Penta peptide. Okay, how many amino acid residues? There are 5. That's why pentapeptide. Um, how many peptide bonds? There are 4. So 1, 2, 3, 4 peptide bond. What is the amino acid at the N terminal? That's alanine. Okay, because the alanine does have an N terminal or free amino group. Okay? What is the amino acid at the C terminal? It's the phenylalanine. Why? Because phenylalanine has free carboxyl group. Its carboxylic acid, its carboxyl group is not uh, involved in the peptide formation. Okay? Unlike the amino acids here, their uh, their amino acid or their amino group and their carboxyl groups are involved or participated in the peptide formation. Okay, so it's just very easy. The leftmost amino acid is the N terminal, and then the rightmost amino acid is the amino acid at the C terminal. Okay, N because it has free amino group. The C terminal is due to the presence of free carboxyl groups or carboxyl group. Okay, at this point, we will see how peptides are named. Okay, for example, it says here, the C-terminal amino acid residue keeps its full name. Okay, remember the C-terminal amino acid residue, that's the amino acid at the rightmost, okay, in the chain, because that amino acid residue has uh, the carboxyl group. Okay, now the rule is, it says um, YL suffix is added to replace INE or ic acid ending of the amino acid name. Okay, except for tryptophan, which uh, YL is added to the name. When you have a sequence, for example, alanine, okay, leucine, and glycine. Okay, I'm just using the single letter abbreviation. Alanine or ALA, okay, the complete is alanine. Okay, remember it ends with INE. So this INE will just be replaced by a suffix YL, so that becomes alanyl. Okay, and then the middle amino acid residue is leucine. Okay, leucine. Okay, the INE once again will be replaced by YL, so that becomes leucyl. Okay, now it says here that I would like to say again, the C-terminal amino acid residue keeps its full amino acid name. Okay, what's the amino acid at the C-terminal? That is glycine. Okay, so to name this tripeptide, you'll have to say alanyl, leucyl, okay, and leucyl glycine. the peptide name has no space in between. Okay? So, this is a tripeptide. Tripeptide because there are three amino acid residues, and the three amino acid residues are linked by two peptide bonds. What's the name of this tripeptide? Alanine, leucyl, glycine. You always begin the naming from the N terminal. Okay, at this point, we will now classify the protein, okay, based on chemical composition. Now, there are many proteins. In fact, in a cell, there are so many proteins, and they vary in shape, function, and they vary in composition. Okay, the first class is called simple protein, in which only amino acid residues are present. No other component except amino acid. Okay? In a simple protein, there could be more than one subunit. Okay? When we say subunit, they are something like this could be polypeptide. Okay, there could be one or more polypeptides in a protein. Say for example, this is protein, okay, and another polypeptide. This is subunit A, and this is subunit B. Okay, but the whole thing is one protein, but it contains two subunits. Okay, it's a simple protein if there are no other non-amino acid component. So again, simple protein is if there are only amino acid present. Okay, it could be mono subunit or mono subunit, yes, or multi sub if there are multi subunit. Okay. Next is conjugated protein. Okay, it says here a protein that has one or more okay, it says here non-amino acid entity. Okay, in simple protein, only amino acid entities are present. Okay, now in conjugated protein, the non-amino acid entities are called prosthetic groups. Okay, the non-amino acid entities are prosthetic group. Now, there could be one or more polypeptide chain, or there could be two or more subunits. Okay, the prosthetic group or the non-amino acid component may be organic or inorganic. Example, lipoprotein. The prosthetic group is lipids. Okay, glycoprotein, the prosthetic group is carbohydrates. Metalloprotein, some metals become part of the prosthetic group.